In today's lecture, we are going to take up a very interesting issue about runaway greenhouse effect in Venus. Why are we looking at it? Venus underwent a dramatic change in climate a long time ago, and Venus and Earth are two planets very similar. We can call them twins. And Earth went in one direction, and we have a very equitable climate in which life has evolved over the last billion years. But Venus is much, much hotter than Earth, and we need to know why Venus is so hot. Okay? And this issue was highlighted by Dr. James Hansen, who was the director of the Goddard Institute of Space Sciences. He said, if we burn all our reserves of fossil fuels, there is a substantial chance that we will initiate on Earth a runaway greenhouse effect. Okay? Although the possibility is very, very small, it is very important to understand when and how this effect may appear. Okay. What is a runaway greenhouse effect? If the quantity of greenhouse gas in the atmosphere of a planet increases with temperature, but the absorption of solar radiation remains constant, the temperature of the planet will increase monotonically. So, in this equation, as all of you have seen before, this is the absorbed solar radiation, this is the emitted radiation, and this radiation will go down when greenhouse gas concentration goes up. Okay? So, when this goes down, and let us say this does not change much, then the temperature will keep rising. Okay? And that is how a greenhouse effect operates. Okay? That is, the planet's absorption of solar radiation is not changing much, but its emission of radiation comes down continuously as the greenhouse concentration keeps increasing. Okay. Now, let us compare the three planets well known to us: Venus, Earth and Mars. Okay. Note that Venus is covered completely with clouds, has a high albedo of 70%, Earth albedo is around 29–30%, Mars has almost no atmosphere, so albedo is 18%. Okay. So, although Venus is closer to the Sun than the Earth and therefore gets much higher radiation, almost twice, it absorbs less radiation than the Earth because it reflects much more. Okay. So, the total radiation absorbed, net radiation, in Venus is around 200 and Earth is around 240. So, the question is, although Venus absorbs less net radiation than the Earth, why is the temperature of Venus more than 700 degrees Kelvin, while that of Earth is close to 288 Kelvin. So, this is the issue we want to understand, why Venus is so hot. People thought it is hot because it is close to the Sun. That would be true if Venus did not have clouds. Since Venus is covered with clouds, a lot of radiation is reflected. So, the actual net radiation gained by Venus is less than Earth. So, the planet Venus is our most Earth-like neighbor in size, mass and distance, of course, closer to the Sun, but comparable. In spite of these similarities and the intense scrutiny it has received during the starting of the space age in the 60s, Venus' surface and atmosphere are characterized by some of the most enigmatic features. This is from a review paper by CRISP published in 2002. Now, the person who pointed out that Venus had a runaway greenhouse is a famous astronomer called Sagan. All of you have heard about him. He has given many popular talks about our solar system. Now, Venus was mystery for a long time because it covered with clouds. It's covered with clouds, you really cannot see the surface of Venus. So, only when astronomers probed Venus in the microwave where the clouds are transparent, they realized that the temperature of Venus at the surface was more than 700 degrees Kelvin. Initially, people did not believe it. There were lots of questions and controversies, but finally, when spacecraft was sent to Venus and instrument landed on the surface, it showed that the temperature was indeed above 700 Kelvin. Okay. Let us look at some of the data of Venus. Okay. It does not have very eccentric orbit, it is almost circular, and its orbital period is 225 days, okay, and is almost close to its rotation period. So, it is very different from Earth, okay, in terms of the speed of rotation, and its orbit is not inclined too much to its plane in which it is orbiting the Sun. Okay. Diameter is very close to the Earth. Mass is also close to the Earth, and gravity is very close to Earth, 0.9 times of the Earth. Albedo is higher, that is the point we want to highlight, and temperature is around 733 Kelvin. The key point here is the concentration of carbon dioxide atmosphere. It is 96.5% in Venus, while in Earth is now around 420 parts per million. Okay. But remember, when the Earth started, when Earth began 4.5 billion years ago, the concentration of CO2 was as high as Venus. So, Venus and Earth started with a similar atmospheric composition. Earth went in a different direction and oxygen appeared on Earth through cyanobacteria, and carbon dioxide went down. So, Earth became much more habitable than Venus. Now, let us again look at the how similar Earth and Venus are. Diameter is very close to each other, mass Earth is slightly heavier, density pretty close. So, it is a planet very similar characteristics of Earth. Okay. Now, let us look at surface pressure. Surface pressure in Venus is about 100 times that of Earth, okay. Just surprising, very thick atmosphere, while Mars has almost no atmosphere. Okay. If you look at the concentration of carbon dioxide, Venus is 97-98%, Earth is now 0.04%, Mars is like Venus 96%, but very little atmosphere. The other gases, Earth has lots of nitrogen, while Venus and Mars have a little nitrogen. Argon around 1%. Oxygen, Earth is unique, has lots of oxygen generated by life, and Mars has a little bit of oxygen, and Venus is almost nothing. Water vapor, Venus has very little, Earth has something which is very critical to our climate, and Mars is very low. So, you can see that the main difference between Earth and Venus is in the composition of the atmosphere, okay, and the surface pressure. Okay. Both play an important role. Once again I want you to see the Earth's composition when it started and now. So, all the carbon dioxide that was there on Earth has almost gone, while nitrogen, which was hardly there initially, is now dominating, and oxygen, which was hardly there, now it is 21%. Now, how about the total amount of carbon, okay, both in the atmosphere, ocean, and in solid Earth? In Earth is about 20.4 kilogram per centimeter squared. In Venus it's close to 30. Okay. And Earth, because has lot of water, has lot of hydrogen, Venus does not have. So the point is that both Venus and Earth have plenty of carbon. Okay. But the main difference is carbon in Venus is in gaseous form in the atmosphere. The carbon on Earth is in the ocean and in the rocks. That is what makes the biggest difference between Venus and Earth. So once again, to remind you that Venus mostly contains carbon dioxide. If you look at minor gases, there is argon, little bit of water vapor, carbon monoxide and sulfur dioxide. Sulfur dioxide produces aerosols, which we will discuss. So we have evidence that Venus lost most of its water and Earth lost most of its carbon dioxide. So that is the key difference between Venus and Earth. Now, since the rotation rate of Venus is different from Earth, the winds in the Venus are somewhat different. It has two circulation cells, northern and southern, while on Earth, which is rotating faster, it has a much more complicated circulation system. We have the Hadley cell in the tropics, and we have mid-latitude cells and a polar cell. Okay. So Earth and Venus are somewhat different in the circulation pattern. Now Venus, as far as we know, has no ocean, and because there is hardly any water, no weathering, which is very important for the carbon cycle of the Earth. Okay. And as far as you know, there is no plate tectonics, no subduction of the carbonates into the mantle, which occurs on Earth. And in Venus, all the carbon dioxide is in the atmosphere, as far as we know. Now, the earliest knowledge about the atmosphere of Venus came from Venera 7, which landed in Venus on 15 December 1970. First soft landing on Venus, and it showed that the surface pressure was 100 times that of Earth, and the temperature was very high, and the temperature was so high that the instrument survived for just 23 minutes. After that, they were gone. Okay. You have only 23 minutes of actual data from these instruments which reach the surface of Venus. So this is data obtained 54 years ago. Okay. Now today we have a lot more data from Venus, because many satellites are orbiting Venus and looking at Venus radiation budget. So what does the budget say? Incoming radiation is 2611 watts per meter squared, Earth is 1360. Most of it is reflected, 1958. Emission is 653 watts per meter squared. Okay. It is same as what is coming down to the surface. And what you notice most interestingly is Venus emits 19,345 watts of meter surface because of the high temperature. Compare that with 390 watts per meter squared that the surface of the Earth emits. So the radiation emitted by Venus surface is very large because of the high temperature, but note that most of it is radiated back by the greenhouse gas carbon dioxide. Okay. So Venus has a very close balance between the radiation emitted, radiation returned by atmosphere, and the radiation absorbed by the surface. Okay. So if you add these two, it comes to this number. So net heating of the surface is very, very small. Now, let us look at the spectra of the radiation emitted by Venus. If you look at the temperature of the flux emitted by Venus surface, it will peak at around 4 to 5 micron. Earth's peaks around 10 micron because we are at 288 Kelvin. Because Venus is much hotter, it will have a much lower wavelength of emission maximum. Okay. This we discussed a long time back in this course. This is the Wien's displacement law, okay, which says that the wavelength at which maximum radiation is emitted into the temperature of the surface is equal to 2898 micron Kelvin. So, we put there 700, you will get around 4 microns emission. Okay. And then compare with the various absorption bands of carbon dioxide. Okay. We all know carbon dioxide is a very strong absorption band at 15 micron, but in Venus the emission surface is very small there. Venus emits more between 4 to 5 micron, where there are other absorption bands of carbon dioxide, one around 4.3 micron, 2.7 micron, 2 micron. So, these are the ones which are contributing to greenhouse effect on Venus, not this one. Okay. Now, on the Earth, almost all the carbon on the Earth is stored in the rocks and sediments, a lot in the deep ocean, some in the mixed layer of the ocean, some in the atmosphere and some in the vegetation. But the key point is 66 million gigatons of carbon is there on Earth, but safely stored in the rocks. In Venus, all this came out into the atmosphere as the temperature went up. Okay. So, that is the key idea you must understand. Okay. So, on the Earth, most of the carbon is in the deep ocean and a small amount of carbon is in the atmosphere. Now, let us compare the temperature profile in Venus and Earth. Venus starts at 720 Kelvin, rapidly declines, and by the time you reach about 50 kilometers, the temperature of Venus and Earth are very similar. Okay. So, at a height of 50 kilometers of surface, temperature of Venus and Earth are both around 200 to 240 Kelvin, and so the real difference is below 50 kilometers. One more graph to highlight this difference. Venus is a green line which goes rapidly down. Earth is a blue line where the temperature 15 degrees centigrade at the surface drops to around 200 Kelvin at the tropopause and then increases in the stratosphere and then goes down. So, you can see that around 50 Kelvin temperature of Venus and Earth are very similar. And if you look at the Venus atmosphere temperature profile, you will see that there are sulfuric acid aerosols, haze, above the troposphere. There is no stratosphere in Venus because there is no ozone, and there are lots of clouds, mostly sulfuric acid droplets. Okay. Now, here is one more picture of the various cloud layers in Venus as far as the haze, okay, containing aerosol particles, and how the temperature varies with height. Okay. One more slide showing the troposphere, sulfuric acid haze and the cloud layer. Now, let us look at the energy budget, which is very important because we have already looked at the energy budget of the Earth. So, we need to now look at energy budget of Venus in watts per meter square per unit surface area of the Earth, okay, taken from a review paper by Lemaye published in Space Science Review in 2018. Okay. So, instead of 1360 we are getting 625 watts per meter squared instead of 340, that is per unit surface area of the earth. Venus gets 625, but most of it is reflected back, 475. Okay. 100 watts per meter squared is absorbed by the clouds in Venus. 30 watts per meter squared is absorbed in the troposphere, and only 20 watt reaches the surface. But that leads to a very high temperature because of the strong greenhouse effect. And you can see 150 watts per meter squared is emitted to space. On Earth it is 240, okay. In Venus it is 150. Okay. So the major difference between Venus and Earth is that Venus has a much stronger greenhouse effect, and the surface of Venus emits something like 19,500 watts per meter squared, but to space it only emits 150 watts per meter squared. So the Venus greenhouse effect is really stupendous, huge, okay, because of high amount of carbon dioxide, and because the surface pressure is 100 times larger, the total amount of carbon dioxide is much higher than Venus on Earth. So let us calculate greenhouse effect on Venus and Earth. And Earth we already saw 390 is surface emission, 240 is the emission to space. So we get 150 watts per meter squared, while in Venus the emission is 16,100 watts per meter squared surface and 150 watts per meter squared to space. So the greenhouse effect is 15,950 watts per meter squared. So it is almost 100 times that of Earth. Okay. Let us look at once more the energy budget in terms of the Earth radiation. So Venus gets twice the radiation from the Earth, 200%, but 152% goes back. Earth gets 100%, of which 30% goes back. Okay. In Venus, only 6% of the radiation coming from the sun is absorbed at surface, while on Earth it is 50%. Okay. In the case of Venus, only 42% of the radiation is absorbed in the atmosphere, and Earth is 20%. So because of these differences, Venus has a big impact on the temperature, but the main effect, all this is on the solar short wave side, but the real effect we already saw in the previous slide is in the long wave, where Venus has such a strong greenhouse effect that most of the radiation emitted from the surface is emitted back to the surface by the atmosphere, and only 150 watts per meter squared is emitted to space. This is what makes Venus very different, this one. And so to show the effect of Venus, we look at what will happen if we remove carbon dioxide from Venus. Temperature of Venus will drop by 420 Kelvin, okay, because carbon dioxide is so important on Venus. Clouds also give a greenhouse effect, you know that, and that will result in a cooling of 140 watts per meter squared. There is a small amount of water vapor on Venus. If you remove that, you will get 70 Kelvin cooling, and there are so many other small gases. So the key point is that the Venus high temperature is maintained by carbon dioxide, clouds, and water vapor greenhouse effect. Okay. We will continue this lecture in the next class.